Good morning, sir. This is Ajay Kumar Bacha. Today, I would like to give a small demo on dehydration. In chemistry, we see there are many molecules which can undergo dehydration. But I would like to discuss about dehydration of alcohols. Alcohols can undergo dehydration in presence of phosphoric acid, sulfuric acid, aluminum oxide, and produce alkanes. Anyway, let me take sulfuric acid as a catalyst and see the dehydration process of alcohols. Suppose let me take the first simple alcohol, ethyl alcohol. Ethyl alcohol I have taken. I would like to heat that on the sulfuric acid. Here, sulfuric acid acts as a catalyst. Consequently, you get here alkene, which is called ethene here, and water molecule. Water molecule. Let us see how the reaction mechanism goes. If you look at the ethyl alcohol molecule, that acts as here Lewis base. So we know that low electron-rich compounds are Lewis bases. Since we are having here lone pair around oxygen, it acts as a Lewis base. H plus acts as a catalyst. From where H plus comes from? H plus comes from sulfuric acid. So H plus acts as a Lewis acid that attacks upon Lewis base and produce an intermediate like this. The intermediate is unstable. Why? There is a positive charge upon the oxygen. Since oxygen is losing a lone pair by donating a lone pair to the H plus ion, it will take up positive charge there. So during heating process, the lone pair will be taken, the bonding electrons will be taken by the oxygen, then produce a carbocation like this. Carbocation like this. Now from this we get alkene. Here you have 3 CH bonds. Let's take one CH bond like this. That the CH bond will become pi bond between two carbon atoms and eventually produce an alkene like this plus H plus ion. Okay, so Lewis acid attacks upon Lewis base and produces an intermediate. Upon heating, a bonding electrons will be taken with oxygen and that goes out as water molecule. Consequently, you get a carbocation there. The carbocation will be converted into alkene by the elimination of H plus ion. So this is the mechanism every alcohols will undergo. But which alcohol undergo fast dehydration? Overall process is the dehydration process, because at the end we see the elimination of water molecule over there. So which alcohol undergoes fast dehydration process? Suppose I have taken here ethyl alcohol. Ethyl alcohol is a primary alcohol because OH attached carbon is connected with one carbon. Likewise, let me take one more alcohol, that is secondary alcohol. Common name of this one is isopropyl alcohol. And we also take another alcohol, that is tertiary alcohol, like this. Now, when you look at these alcohols, which alcohol undergoes fast dehydration? Fast dehydration. So already we have seen that during the dehydration process, ethyl alcohol will produce ethyl carbocation. If you do the same mechanism with isopropyl alcohol, that will produce isopropyl carbocation. Likewise, if you see here, tertiary butyl alcohol will produce tertiary butyl carbocation. Tertiary butyl carbocation. Now, depending on the stability of the carbocation, the reaction speed or rate varies. Look at here. So, ethyl alcohol will produce ethyl carbocation, which is primary carbocation. Secondary alcohol will produce secondary carbocation. Tertiary alcohol will produce tertiary carbocation. Then, which is more stable? Tertiary carbocation is more stable because this tertiary carbocation, we see the carbocation stabilized by inductive effect as well as hyperconjugated structures. It would show 9 hyperconjugated structures. Here also, this is also stabilized by 2 plus side groups and 6 hyperconjugated structures. Here it would show 3 hyperconjugated structures and with 1 methyl group which is acting as plus side group. So overall, all molecules, when you look at, this is having 3 plus side groups and produce 9 hyperconjugated structures. Therefore, this is more stable carbocation. Since this is more stable carbocation, the corresponding alcohol will be undergoing fast dehydration. When it undergoes fast dehydration, we get alkene. Generally, alkenes will be the products during the dehydration process. The conclusion of this topic is now So tertiary alcohols undergoes fast dehydration as compared to secondary and primary. Likewise, you can also take some aromatic alcohols. We see some aromatic alcohols and how they will be undergoing dehydration process, and which alcohol will go fast dehydration process. So let me take here benzyl alcohol. So we know this is the formula for the benzyl alcohol. And let me take one more alcohol, diphenyl, diphenyl methanol, diphenyl methanol. Let me take one more, triphenyl methanol, triphenyl methanol. So alcohols I have given, these are all aromatic alcohols. Now we would like to see which one undergoes fast dehydration. Already we have seen aromatic alcohols, primary alcohol, secondary alcohol, tertiary alcohol. Now in this case we see. So benzyl alcohol is taken, diphenyl methanol is taken, triphenyl methanol is taken. Okay, during this dehydration process, same mechanism. Express attacks upon the alcoholic group. Afterwards, water will be eliminated upon dehydration, and then we get a carbocation. If this undergoes dehydration, we get here benzyl carbocation. So you will get here secondary carbocation. Here you get here tertiary carbocation. Again, based on the stability of carbocations, the rate of dehydration varies. Okay. So this is tertiary carbocation. This is secondary, tertiary, primary. These carbocations stabilized by what factors? These carbocations are stabilized by resonance. So this ring will show resonance here, okay, and stabilize the carbocation. Here this ring will show resonance, this ring will show resonance, here this ring will show resonance, this will show resonance, this will show resonance. So because of resonance structure, the carbocation is stabilized. So every ring will participate in resonance and stabilize the carbocation. But which is more stable? The one which is having more benzene rings or more phenyl rings would be more stable, because if you look at here, this will produce resonance structure, this will produce resonance structure, this will produce resonance structure. Three phenyl rings are there, three phenyl rings will involve in the resonance structures and stabilize carbocation high. Here only two phenyl rings are there, here one phenyl ring is there. So number of resonance structures produced more is by the tertiary alcohol. So due to that, the tertiary alcohol, a triphenyl methanol will be undergoing fast dehydration, whereas benzyl alcohol will undergo slow dehydration. So this is how we will discuss the rate of dehydration of the alcohols. Thank you for the listening.